I am going to put 30 random words on the screen for the next 10 seconds. Do not write them down. Just try to remember as many as you can. Ready? Go. Stop. Before you even try to list what you saw, I can tell you exactly which words stuck in your head. You likely recalled the very first couple of words on the list, and the last few right before time ran out. You probably also caught related pairs, like the words left and right. And I know for an absolute fact that you remembered the most absurd, completely out of context item in the entire sequence: Santa Claus. Memory follows a strict biological algorithm that automatically prioritizes the beginning of an experience, the end, things that are associated, and things that are completely absurd. Because our brains process information processing through this highly predictable pattern, sitting down to blindly force-feed yourself facts for hours goes directly against your biology. It guarantees you will forget what you read. Look at the standard, socially accepted way to learn something hard. You clear your schedule, sit at your desk, and focus on a single topic for an unbroken 2-hour block. This graph maps exactly what happens inside your brain during that marathon session. On the vertical axis, we have the percentage of information you actually retain, and the horizontal axis tracks your 2 hours of time. At the very beginning of the session, your brain is at its highest point of recall. You easily absorb those first few concepts. And as you wrap up your work exactly at the 120-minute mark, your brain gets a surge of focus, creating a second high point of recall right at the finish line. But between those two peaks is a massive 90-minute dead zone. Retention completely flatlines. A single continuous block of focus creates a saturation point where the brain stops encoding new data. You might be staring at a textbook for 90 minutes, but your effort is essentially wasted. If the brain only reliably remembers the beginnings and the ends of a learning period, we have to artificially manufacture more of them. Instead of one marathon session, you divide that exact same 2-hour window into 4 distinct 25-minute sprints, separating each one with a strict 5-minute mental break. Because you are starting and stopping more frequently, each of these shorter sprints generates its own initial and final retention spike. You now have 8 high points of recall instead of 2. When we overlay this new chunked retention curve against that original 2-hour valley, the massive dip in the middle is eliminated. You capture significantly more data without adding a single minute to your study schedule. By restructuring the timing rather than increasing the effort, you multiply your absorption rate. Even with perfectly structured 25-minute sprints, human memory still inherently degrades as time passes. Within just 24 hours of learning something new, your brain naturally discards 80% of that data. This 80% drop explains why so many students resort to cramming. They study early, naturally forget almost everything over the next few weeks, and then panic 2 days before an exam. Cramming forces your brain to relearn forgotten material from scratch, creating weak memory links while under intense stress. Learning efficiently on day 1 is useless if the memory isn't anchored before the 24-hour biological purge occurs. To interrupt that drop-off, you have to use a specific timed antidote known as strategic revision. This chart shows exactly how to flatten the forgetting curve. You review the material exactly 10 minutes after your initial study session, again at 24 hours, once more after a week, and a final time at the 1-month mark. Let's compare the total time investment. A student who relies on last-minute cramming will spend 3.5 uninterrupted hours relearning a subject from zero. Meanwhile, a student using those 4 spaced strategic revision intervals will spend a total of only 2 hours and 50 minutes. Because those short review sessions happen while the information is still fresh, you are reinforcing the neuroconnections, the thought wires between your brain cells, before they decay. This results in comprehension that is 4 times more effective than the conventional method. Memory follows a predictable, mechanical pattern, and once you see that pattern, you can control it.